Are you seeing something on the screen?
Yes, sir.
Something is seen? Okay. Let me go to slideshow from beginning.
Yes, sir. Visible.
Yeah, okay. Let me go to the pointer option. Pen. Yeah, yes. Okay. So the topic is called as magmatic concentration. That means magma plays a role in concentrating mineral deposits. That's why it's called as magmatic concentration. Okay. What does it tell? What exactly is happening? Try to look into the aspects of geology. Certain accessory, uncommon constituents of a magma. Ratan is calling. Ratan साहब, नमस्कार नमस्कार. अभी मेरा क्लास है 1 घंटा के बाद में आपसे बात करूं. बताइए बताइए. ठीक है ठीक. Okay. Thank you. So certain accessory uncommon. What is this? What is accessory? What is uncommon? We should understand. Let us take a basalt, which many of us are quite familiar. Okay, basalt. Okay, basalt is produced by a mafic magma. Is it right? Produced by mafic magma. What does the mafic magma will have? If you see the compound, if you take a basalt, try to analyze, it will have SiO2. It will have aluminium. It will have magnesium. It will have iron. It will have certain components, like when analyzing, you will not be able to detect the platinum in the rocks. Not much. Gold, very less. Then silver. They will not be the major components, not in percentages. If you stick percentages, or the Si, aluminum, iron, magnesium, manganese, calcium, all these things. Okay, so that they are called as the common constituents. So that means there's something called uncommon. What is uncommon? Platinum, gold, silver, mercury. They're all uncommon. So these uncommon ones, when they get concentrated in sufficient size, then it becomes a metal deposit. But let's consider a class of 60. A class of 60. Okay. So you will have students, 60 students from different parts of India. Is it right? Orissa is here, sitting here. A person Madhya Pradesh is sitting here. A person from Rajasthan. A person from Haryana. No, like this in different rows. Okay. Suppose we will allow them to rearrange. Okay, rearrange. In this particular part of the class, only Madhya Pradesh students are sitting. This part of the class, Haryana students are sitting. This part of the class, Rajasthan students are sitting. Here, Andhra students are sitting. So this becomes a concentration of Rajasthan, concentration of Madhya Pradesh, concentration of Andhra Pradesh, concentration Haryana. So this is what happens in a deposit. Okay, and when you study carefully these deposits, there exists some relationship. The deep-seated intrusives, whether the deep-seated rocks or intermediate type of rocks, with the intrusive rocks, there is a relation. Okay, and igneous rocks with certain composition also happens to be valuable. So in this process, the whole rock becomes a body, or a part of the rock becomes body, or offshoot of the rock becomes a ore body or a mineral deposit. Is it right, Akshat? Something is clear?
Yes, sir. Yes, sir.
Okay. So when you try to do field work or try to collect the data of different igneous rocks, okay, so there is some association. There is some association. For example, you see the chalcopile, siderophile elements. Okay. Chalcopile like copper, lead, zinc. Siderophile elements like chromium, nickel, platinum. Okay, all these things, they're associated with certain mafic rocks. That means rocks having mafic mineralogy, rocks having pyroxenes, olivine. Is it right? So this type of combination is. That means there is some relation between rock and the type of minerals occurring in a particular deposit. Lithophiles, lithium, tin, zircon, uranium, wolfram, all these things are found in the felsic rock, which are granites, are associated rocks. Granites are associated granitoids. When you analyze these rocks, and when you go to the field, for example, when you try to study the area, these rocks will have different types of metal deposits, and these will have different types of metal deposits. So all these things helps in understanding the orogenesis of a particular area. Yeah. So this is a picture. Are you able to see the diagram, Amit? Amit?
Yes, sir.
What do you see in this diagram?
That is the structure of continental crust.
You make your laptop computer clear. When I say, is it clear to you?
Yes, sir.
Yes or no?
Yes, sir.
Then when you are talking, why I am not getting clear? That means there is some communication gap. I have put a cross to you. I have put a tick to Akshat. Anshika? Anshika is there? Anshika? I have put a cross. Anubhav?
Yes, sir.
Okay, is it Anubhav speaking?
Yes, sir, I'm speaking.
Okay, yeah. What do you see on the screen?
Sir, continental crust architecture showing a main type of igneous related ore deposit characteristic of this environment.
Okay, come on, read. What does it tell? Read the first one. Copper, molybdenum, lead, zinc. What does it indicate? Where does it fall?
Sir, it's falling in S-type continental crust.
Yes, type. Are you very clear? Your eyes are all right, or there is some problem with my eyes? Copper, molybdenum, lead, zinc, that particular box, where does it go? This box here, where does it go? What is it written here?
I-type.
What is I-type? What is I-type? Then next question comes, what is I-type? Do you know what is an I-type?
No, sir.
Did you study igneous petrology?
Yes, sir.
Then, if you study igneous petrology, you should know what is I-type. Let me make some remarks on you. Okay. Next, Aryan.
Let me
Yes, sir.
maybe, sir.
Only one. Akshat is over. Akshat का कितना interact करना कर लिया हमने. Now the turn of Aryan.
Yeah, yes, sir.
Aryan. Aryan,
So,
tell me what is
Sir, am I
I-type?
audible?
Yes, yes.
Sir, I-type or granite means they are
Very good.
saturated
I-types
in.
are granite.
No, sir.
Very
Like
good. Very. Yeah, I-types are igneous granites. It is having certain characteristic features. Okay.
yeah,
For further information, you please refer to some books or Google, whatever you do anything. Okay. It is basically I-type granite. Okay, you are right. Good.
yeah.
Aryan is good.
Okay.
Come on, let me go to Devansh. Devansh? Devansh is there?
Yes, sir.
Okay. What
Yes,
does
sir.
this box show? What does this SN and W show? What are these? What is SN and what is W?
So it is chemical element, sir. Tin,
Of
SN
what?
means tin,
Of what?
W is tungsten.
Very good, very good, very nice. I'm very happy. Okay. So where does this box go? What is this? What is this? What is this? What is this? This I type. What is this? Something is wrong. छोड़ दो. Devash, छोड़ दो. Yes, let me go to Garima. Garima. Now come on, tell what is this S type? What does S type indicate? You don't know. Can you make some attempt to find what is S type? Deposition. Do you call the granite deposition? Do you call granite deposition? Can I say Garima is a boy? That's type. Okay, do one thing, Garima. You give a talk next week. Next week, Monday. Now you have 2 days time. I will give you about 15 minutes time. Prepare a PPT on S type of granites. You have to give 15 minutes. First, you prepare a write up. Send it to me for 3-4 pages, S type. Then you give a small presentation. Okay, next, diamond. There is a box on diamond. Diamond, copper, Re, phosphorus. Okay, it's coming here. And it's showing kimberlite. So kimberlites are associated with this type of ones. And this particular box, chromium, copper, nickel, PG, vanadium, this box is coming here. So these are ultramafic rocks. Intrusion, once again, intrusions. Okay. And below that, there is once again intrusion, which is showing towards tin, wolfram, copper, gold. Okay. And this particular box, the shallow level is uranium, thorium. So that means that different metal deposits are related in the continental crust in different geological environment and different type of rocks. Is it clear? Iftikhar, what is your full name? Iftikhar Hussain.
Iftikhar Hussain, yes, sir.
Yeah, Iftikhar Hussain. Is it clear?
Yes, sir.
That means the continental crust, when people to go for detailed study of the continental crust, different metal deposits are associated with different types of rocks, right? What is this? Jay is there?
Yes,
Jay
sir.
has joined? Finally Jay has joined. Very good. Yeah, come on. What is it written there? Come on, tell me.
So copper, zinc, and cobalt.
Cobalt.
And the mid-oceanic ridge are settled at that.
Okay, where does it go? Copper, cobalt, zinc. What is it written here?
VMS.
And what is happening here? What is this?
The mid-oceanic ridge.
Mid-ocean. That means you have deposits like copper, cobalt, zinc in the mid-oceanic ridges, which are called as the volcanogenic massive sulfide deposits. Okay, so that means these type deposits are associated certain environment and certain environment, certain rocks. Is it right?
Yes,
Done?
sir.
Now let us come here, this box. Let us talk to Jay is okay, not bad. Yeah, okay. It was able to. Kanishk. Let's go to Kanishk. Kanishk or Kanak?
Yes, sir.
Kanak. What is this box? What does this box tell?
Sir, this is chromium, nickel, and platinum.
Fine. So what does this box indicate towards? Pyroxene, plagioclase, olivine bearing cumulates.
Sir.
Where will you have this type of minerals in a cumulate environment? Where will you have? Hello. Okay. Okay. Yeah. Thank you very much. I will talk to you. I'm in a class now for my MTech students. I will talk to you. No problem. I'll talk to you. Your number I will talk to you. Yeah, sure. So cumulates, no? Where does the cumulate form? What is the meaning of cumulates?
Sir, cumulates are the circumulated type of minerals in this layer.
Pardon?
These minerals are accumulated here.
Cumulate. What is the meaning of cumulate? Can you tell me? I do not know. I'm a layman.
Basically, like when we have a layer and there are some type of minerals that are present here in the layer that have been formed or deposited in that certain layer, they are known as cumulates.
Cumulates are the accumulations. They are accumulations. That's called cumulate. They are accumulated part of the magma. When magma is crystallizing, certain minerals with high density will start going down, sinking. They're called cumulates. Is it right? So such a thing happens mostly in the ultramafic rocks. Is it right? The ultramafic rocks are your dunites, peridotites, erzbergites. देखो erzbergite has come. देखो you see here. Erzbergite, dunite has come. Yeah. Tectonized. That means tectonically disturbed. So they are mostly the ophiolites. Ophiolites. Have you heard of the term called ophiolites? Ophiolites. Ophiolites will have this type of geological setting, and you will have mineral deposits like chromium, nickel, platinum. So when you come across in the field this type of cumulate with ultramafic rock, then you can start thinking of a chromium, nickel, platinum deposit. Okay, so if you try to put a borehole from right from the ocean to the bottom, you will get different layers. You will get the lerzoolite, you will get the spinel lerzoolite, you can get the cumulates, you will get different type pelagic sediment at the top. You will get different oceanic environment. So certain mineral deposits associated with this type of rocks. Once again, okay? All right. Is it Kanik speaking or Kanak?
Sir, Kanak.
Kanak, okay. You have some interest. So, you're talking about the crust. So the crust is 35 to 40 kilometers thick. You have the upper crust, lower crust. Upper crust is felsic. The silicate rocks, the granitic and the alkaline rocks. That means distinct mineral deposits occur in distinct rock types. Right or wrong? Right or wrong? Nickel. Nickel is there?
Yes, sir.
Yes. Hmm. So that means you have mineral deposits in different types of magmatic rocks. So if you try to see the crystallization of magma, have you ever seen the crystallized magma? Have you people seen, any one of you? How magma crystallizes? No, yeah, even I did not see it. Only thing is, we can infer. We can infer through the study of rocks. Okay? So we can infer through the study of rocks. So if you try to see the magmatic process, there is something called early magmatic. Certain minerals crystallize. The ore minerals crystallize early part. It is something like this. Some people get up early in the morning. Is it right? Early rise in the morning. They get up at 5 o'clock. They do all the morning duties. They go for a walking. Then they come. They have a cup of tea, breakfast. That is one group of people. Another group of people, they will sleep very late in the night, and naturally they cannot get up in the morning. So they will be late rises. The same thing. Certain minerals will crystallize at a very late stage, or late magmatic. So let us see what is happening early magmatic. In early magmatic, you can have dissemination. Suppose you can have a rock body, it crystallizes, but certain components are disseminated here and there. And if this is a valuable, like diamond, then it becomes a deposit. They are called as the early magmatic disseminated deposits. The most classical is diamond pipes. Corundum deposits. Corundum can become a gem variety, can become a sapphire or a ruby, right? So, in the early magmatic crystallization, certain components are trapped here and there. When the magma is crystallizing, they are called as the dissemination deposits. And sometimes they are called segregation. When the magma crystallizes, because of the heaviness of the crystals, they will come down at the bottom. They will come down at the bottom and they will form layers. So, this is called as segregation. Crystallization takes place, there's a differentiation of the magma, and accumulation takes place. The most classical is your Bushveld chromides and the Stillwater Montana chromide. Of course, this is more detailed. Simple crystallization in case of dissemination, most deep-seated. The magma will have granular igneous rock. The early crystals are disseminated. It is valuable and abundant, just like diamond. South African diamonds, crystallized deeper part of the magma. There are disseminations, segregation. What happens? Segregations, daily concentration of valuables because of magma gravitative crystallization. The gravity operates here. The most famous is the chromium segregations. But it's a very good size and richness, it becomes a deposit. So sinking of the early crystals, the reason is when the magma is crystallizing, it will crystallize number of components, but certain crystals will go down and will form layers. They'll be lenticular, they'll be small deposit, they can be pods, they can be stringent, they can be layered. You'll see different physical expressions. Am I right, Nikhil? Have you ever seen any ultramafic rocks in the museum?
Yes,
Nikhil is
sir.
there?
Yes, sir.
Have you ever seen any ultramafic rocks?
Yes, sir.
What are the rocks, ultramafic rocks?
We have some olivine crystals, I guess.
Olivine crystal. Oh, very good, very good. Very good. Have you seen a rock with olivine crystals?
Yes, sir. Like I remember I seen, but I can't
Pardon?
recall that. I have seen most of the rock in the museum, but can't recall that right now.
You cannot recall. Yeah. Next time when you come and the corona is over, you please come and see. Okay.
Yes, sir.
Yeah. Ultramafic rocks are dark colored rocks. Mafic, very high mafic content. They look dark green, very green. So they will have this type of crystal. Because olivine will be the first one to crystallize. But the olivine will have a lot of chromium, chromite. Yeah, this is a picture it shows, depicts how it happens. You have magnetic chamber, you have certain crystals. Okay, you have the olivine crystals, they're all forming all. Okay. And these crystals, the black ones, are still in the melt. Because of shrinking, they will form the next layer. And some other crystals are there, white ones, mostly feldspars. They will form the next layer. So you will have layered complex, olivine layered, then you have the chromium layers, then you will have the feldspar layer, then something else will be there. So these are called as the layered igneous rocks. They will settle at different rates. Yeah. So temperature and as well as the density plays a role. Right? So when a process operates, you will have this type of stratiform bands. Provide. So can I have Mr. Piyush? Piyush,
Yes, sir.
why we use stratiform bands?
So they form, sir, as they sing, they form layers, sir.
But the stratification is mostly used in sedimentary petrology.
So stratiform bands. Sir,
Do you
no
know what is
idea, sir.
stratiform? What is stratobound?
Stratiform, sir.
You please
Like
do a
it.
small assignment. Is it Piyush speaking?
Yes, sir.
Yeah, please do a small assignment on stratiform and stratabound deposits.
Stratiform
There is
and?
something stratabound.
Okay, sir.
Stratabound. Let me write stratabound. Yes. T R A T A B O U N D. Stratabound.
Okay, sir.
One is called stratiform. Stratabound. Now you do a small assignment and show me the next class.
Okay, sir.
This is for nickel. No, this is for Piyush. I am noting down. Piyush. Because we should understand. Otherwise, no, we will be just in the dark. So in this particular process, that's what they call stratiform bands. A chromite of uniform thickness for several kilometers. The most famous is Bushveld chromite. Not only Bushveld chromite, it has got platinum reefs also by sinking of the early formed crystal. So sinking of the early formed crystal, under certain, not always will happen. Certain conditions, it will develop this type of chromite deposits and platinum deposits. So these are the pictures you see here. Of course, you see these ultramafic rocks. Suddenly you get a layer of chromite. Again you get rocks. Again you get 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 chromite. So like that, you will have stratification. Just like sedimentary rocks. Of course, this is called as magmatic sedimentation. Anyhow, our Piyush will give a talk on this stratiform, stratabound, so things will more clear. So stratabound stuff. We will lecture. First assignment, then Padme is in a small talk. So these are once again underground exposures of the rocks. Yeah, this is what when you go to the field you will find. Go to South Africa Bushveld complex, the most famous Bushveld complex, runs for 30 kilometers, this particular Bushveld. Okay, if you take a section of it, you will find the chromitite, you will find the chromium rich layers, then you find the gabbro, you find pyroxenite. Yeah, to start with pyroxenite, then again you have the chromitite layers, again pyroxenite, again chromitite layers, then you have bronzonite, pyroxenite, once again type of pyroxenite. And again you have the pyroxenites, bronzonite, then again chromitite layer, then you get a lot of gabbro changes. The rock type, there's been differentiation until differentiation. Then again you get chromitite, then you get a lot of gabbro, and at the end you get anathracite. So these are called as the layered complex. Within the layered complex, you get the chromitite bands or stratiform. Okay. So after that again you have rocks, then again you are getting magnetite. So this is late magmatic. We will discuss when late magmatic comes. So basically these are settling of the crystals in the magma chamber that can concentrate the minerals. Take spinel. Basically spinel is a group of one. It can be a chromite, magnetite, it can be anything because they are substituted. When iron substitute, it becomes a magnetite. When manganese substitute, manganese bearing mineral. Okay, when iron substitutes for magnesium, it becomes a magnetite.
Yes, sir.
Am I audible?
Now you're audible, sir.
What happened in
सर
between?
वीडियो रुक गया था कुछ देर के
वीडियो ठीक है, बट ऑडियो आना चाहिए.
नहीं सर,
दोनों
ऑडियो
अटक
भी
गए,
चला गया
कुछ भी नहीं आ रहा था,
और स्लाइड्स
ऑडियो
भी
भी
चली
नहीं
गई.
आ रही थी, पॉज हो गया
Stuck हो
था.
गया. Okay. Now I am asking Prajwal. Prajwal is there.
Yes, sir.
Prajwal.
Yes, sir.
Babu. What books do you have?
So,
E-books.
sir, that Saket shared. I forgot the name
What is
of the author.
Oh God, oh God, oh God, something is wrong. That means you have not even seen the book properly. You did not even see the book. My Lord. But Sahil, what is his name? Sahil, Sahil. Sahil,
Yes, sir.
what books do you
Yes,
have?
sir. I mean,
What books do you have?
sir, this economic geology by Walter.
Water pole, okay. So,
Yes.
I think many of you must be having water pole or any other book. So my feeling is that you people should write a small write-up, all of you, for about 3 pages on the early magmatic concentration. This is the first
Sir, can you
assignment.
repeat the question?
I am typing. I will chat. I will put in the chat box.
Okay, sir.
I have chat. Your first assignment. Apart from the normal assignment I have given to some students, for all. First assignment for all is early magmatic concentration process. For metal deposition. Formation. Okay. So this is the first assignment. All of you have to write in hand. You have to take about 3-4 sheets, maximum 3 pages or 4 pages. Write in hand. Take a scan it and post it in my mail in R Krishnamurthy at es.iitr.ac.in.
Sir, where is the question?
I have written.
Okay.
Your first assignment for all is early magmatic concentration process for mineral deposit formation. Minimum 3 pages. Minimum 3 pages. Minimum 3 pages. To be submitted by, let me give 5 days time. Friday, Saturday, Sunday, Monday, Tuesday. Yeah. You can submit on Wednesday, by Wednesday. Wednesday. What is the date? Wednesday, August. Yeah, 1st of September. Wednesday. 1st of September. Handwritten on white sheet with the diagrams, and scan it. Scan and send. Done? Is it clear?
Yes, sir.
Yes, sir.
Sanmai?
Yes, sir. Yes, sir.
Sanmai? Is it clear? What is clear to you? Sanmai?
Yes, sir.
What is clear to you?
Sir, I have to submit assignment by Wednesday.
And what? What is the topic?
Early magnetic concentration. Am I audible, sir?
Yes.
Early magnetic concentration.
कौन है? दानवीन कौन है? दानवीन नया ज्वाइन।
Yes, sir.
दानवीन
Yes, sir.
क्यों इतना लेट ज्वाइन किया क्लास में?
सर एक्चुअली सर
ज्वाइन
घर
नहीं
पे
करना चाहिए था।
सर लाइट गई हुई थी
No
घर पे
excuse.
तो
No excuse. No, I don't like excuse.
सर
No excuse.
सॉरी सर
Anyhow, I am not giving
तो
attendance.
नेक्स्ट टाइम
All right. Well, if you come to the class, if you do the things, then you will get it. Otherwise, it was very simple. There policy fantastic simple. If you come to the class, attend the class, you are sincere, you will do it. Otherwise, ऐसा करेंगे वैसा करेंगे. Okay, have a nice time to all of you.